And hello and welcome. Yes, it's the June show. Yes, we missed May, but then again, May was a very busy month for most of us. The lockdown blues, I suppose you could say, was May's treat. But we're not talking about James May, Captain Slow. We're actually talking about the month for a change. So anyway, of course, it's June, and what does June always bring to CometWatch? The Asteroid Day show. And of course, can't have Asteroid Day show without two very good experts on the subject. So we'll get round to them in a few minutes. But as always, Mary and I are going to get stuck into the show. So it's hello from me, Nick Yvetts.
And hello from Mary McIntyre.
Hello, everybody. Hello. Um, I will say that only once. Okay, so as usual, we will get stuck into the visual observations page. Very nicely presented to us, as always, by Jonathan Shanklin's great work. And I want to thank Nick James as well for letting us use it. So, May the 4th, discovery of 2020 J1 sonar reported.
And May the 8th, Warshot-Bloom-Plod reports a Kreutzgruppe comet in real-time C2 images.
May the 10th, Warshot-Bloom-Plod reports 2 Kreutzgruppe comets in real-time C2 images.
And May the 10th again, we have Mazanori Uchina reports 2 Kreutzgruppe comets in real-time C2 images.
On May the 11th, Peter Barrett reports a cracked group comet in archive C2 images.
And May the 11th, Peter Barrett reports a Maya group comet in archive C2 images.
May the 11th, yet again, Zai-Jian Zhu reports a Kreutzgruppe comet in real-time C2 images.
And May the 12th, Warshot-Bloom-Plod reports a Kreutzgruppe comet in real-time C2 images.
And May 13th, Peter Barrett reports a Maya group comet in archive C2 images.
And May the 14th, 2019 LM4 P Palomar is found to show cometary features.
May the 14th, Warshot-Bloom-Plod reports a Kreutzgruppe comet in real-time C3 images.
May the 16th, Mazanori Uchina reports a Kreutzgruppe comet in real-time C2 images.
May 18th, May 18th, Mazanori Uchina reports a Kreutzgruppe comet in real-time C2 images. I promise you I have not been drinking.
May the 19th, Warshot-Bloom-Plod reports 2 Kreutzgruppe comets in real-time C2 images.
May the 19th, again, Mazanori Uchina reports a Kreutzgruppe comet in real-time C3 images.
And May the 20th, Mazanori Uchina reports a Kreutzgruppe comet in real-time C2 images.
May the 21st, discovery of 2020 H7 Lemon reported.
May the 21st, we have the discovery of 2020 H8 Pan-stars reported.
May 21st, yet again, discovery of 2020 K1 Pan-stars reported.
And another on May the 21st was Warshot-Bloom-Plod reporting a Kreutzgruppe comet in real-time C3 images.
May the 22nd, cometary nature of 2019 LD2 Atlas publicised.
May the 27th, Warshot-Bloom-Plod reports a Maya group comet in real-time C2 images.
Okay, May 22nd, Warshot-Bloom-Plod reports a Maya group comet in real-time C2 images.
May the 23rd, 2019 LD acknowledged as being a comet.
May the 23rd, Warshot-Bloom-Plod reports a Kreutzgruppe comet in real-time C2 images.
May the 24th, discovery of 2020 K2 Pan-stars reported.
May the 24th, discovery of 2020 K3 Leonard reported.
And May the 24th again, discovery of 2020 K4 Pan-stars reported.
May the 25th, discovery of 2020 H9 Pan-stars reported.
And May the 26th, 2019 K6 was redesignated as a comet.
May the 28th, discovery of 2020 K5 Pan-stars reported.
May the 28th again, Mazanori Uchina reports a Kreutzgruppe comet in delayed C2 images.
May the 28th, Warshot-Bloom-Plod reports a Kreutzgruppe comet in real-time C2 images.
May the 29th, Warshot Bloomplod and Michael Basiada reports a Kreutzgruppe comet in real-time C2 images.
May the 29th, Warshot Bloomplod reports a Maya Group comet in real-time C2 images.
And May the 30th, 2 Aten-type asteroids reported to show non-gravitational motion.
May the 30th, Warshot Bloomplod reports a Maya Group comet in real-time C2 images.
May the 31st, Warshot Bloomplod reports a Kreutzgruppe comet in real-time C3 images.
May 31st, Warshot Bloomplod reports a Kreutzgruppe comet in real-time C2 images.
And on June the 1st, Masanori Uchino reports a Kreutzgruppe comet in real-time C2 images.
June the 1st, discovery of 2020 K6 Rankine reported. Well done, David.
Yay! June the 2nd, Warshot Bloomplod reports a Kreutzgruppe comet in real-time C2 images.
June the 2nd, discovery of 2020 K7 Pan-stars reported, and on June the 3rd, the update was done. Now, as always, if there's no recent updates, you can always try the German Comet Group page, or your Yoshida Yoshida's page. Or, if you're really feeling bold, you can go to Liga Iberoamericana de Astronomía for observations. Gosh, that's a mouthful. I fully admit my foreign language skills are getting better, but then again, I'm taking Japanese, Korean, and I have taken a class in Thai. So,
A lot of practice.
yes, and a lot of headaches too. Okay, so current comet magnitudes and observable region for June the 3rd. Having said that, I must admit, as an astronomer, having the linguistic skills is a real benefit, because I feel in translation sometimes a lot of useful stuff gets lost. So anyway, moving on. 2019 U6 Lemon, magnitude 5.5, steady. 20 degrees north to 90 degrees south. It's an evening object, last visually observed May 2020.
2020 F3 Neowise, magnitude 6.5, brightening, observable 5 degrees south to 80 degrees south. That's an early evening object. Last visual observation was May 2020.
2017 T2 Pan-stars, magnitude 8.5. It's steady, 50 degrees north to 15 south. It's an all-night object. The last visual observation was in June 2020.
2020 F8 Swan, magnitude 8.5 and fading, currently at poor elongation, last visually observed in May 2020.
And also we believe it's supposed to may not survive its encounter. This will be sad. It's a nice comet. Okay,
Yeah.
58P Jackson Neumann. It's magnitude 10, possible outburst. 20 degrees north to 55 degrees south. It's an early morning object. The last visually observed May 2020.
2019 Y1 Atlas is at magnitude 11.5 and fading, observable 50 degrees north to 20 degrees south. It's an all-night object. Last visual observation May 2020.
88P Howell, 13th magnitude. 13th magnitude. It's bright, 50 degrees north to 70 degrees south. It's an evening object. Last visually observed May 2020.
29P Schwarzmann-Wachmann, currently magnitude 13 question mark. Obviously that varies. Currently at poor elongation, last visually observed in February 2020.
2019 Y4 Atlas, magnitude 13, fade, poor elongation, last visually observed May 2020.
We have 2018 N2 Assassin, that is mag 13 and fading, observable 50 north to 30 degrees south. That's an all-night object. Last visual observation was January 2020.
2019 N1 Atlas, 13.5 magnitude, bright, 50 degrees north to 10 degrees south. It's an all-night object. Last visually observed May 2020.
And finally we have 246P Niet. That is mag 14 and steady, observable 50 south to 40 degrees south, 50 north to 40 degrees south. That's visible in the evening. Last visual observation was May 2020.
Now, as always, the observable region is an approximate indication of the latitude at which the comet may be seen. Obviously, under good conditions, comets may be visible outside this range. The period when visible is, of course, for the UK. If the comet is visible from the UK, otherwise 40 south or the equator is appropriate. The last visual observation is, of course, as received by the BAA Comet section. Details are often updated on the basis of observations published elsewhere. Beginners, I will admit, will find comets fated in about 7th magnitude difficult to locate. There are finder charts and more information below on the BAA Visual Observations webpage. So if you do want to have a go for these, and you have, I would say, a decent telescope, probably 8 inches for a reflector and above, then you'll find the finder charts there. News and highlights. 2017 T2. It is within binocular observation range, but it does need large binoculars and or dark skies. It's unlikely to get much brighter than at present. However, it will remain well placed for observation until at least October 2020. It will be difficult to observe, obviously, until the moon leaves the skies. 2019 U6, it may reach 5th magnitude at perihelion. However, it's believed that the current rate of brightening is unlikely to be sustained, and the absolute magnitude is relatively faint. It won't become visible to UK observers until July, which is after perihelion. The other two comets, 2020 F3, should be another one to look forward to. It may reach 4th magnitude or brighter at perihelion, but again, it's brightening at a rate that may not be sustainable, and it does have a relatively faint absolute magnitude. It may become visible in the UK in July. The BAA Comet section does always welcome observations from all comet enthusiasts, whether members of the BAA or not. An advantage of joining the BAA, of course, is that you get to read the papers on comets published in the BAA journal. And of course, there's all those lovely section meetings, but you don't have to be a member to attend them. So the December Journal of 2019 included a paper, The Brightest Comets of 2015, and there are further papers in press or under review for 2016 and 2018. Well, so a few nice comments there, I would believe, but of course we are going to digress a little bit, and we're going to have a wander into the sky, and of course it's about those things which, well, they tend to worry people, don't they, Mary? Hello, Mary?
Sorry, I was coughing and forgot to unmute myself. Press love to get crazy about asteroids when there's one passing close, even when it doesn't get that close, really.
Yeah,
whiz everyone up into a frenzy.
Yes, observation comments like, it's going to be as big as a stadium. Okay. And then they have this lurid artist picture of something entering the Earth's atmosphere. However, fear not, we have two of our very good friends at hand. And our friends, would you like to introduce yourselves?
Yeah, hello Nick. This is Daniel Bamberger from Germany. And I'm joined by my colleague Guy Waltz from the Northolt Branch Observatory. Hi Guy.
Hi. How are you doing? You alright?
Yeah, we're all good, thank you.
Yep, it's good. Life is good, it's getting better, and there's chilies. Anybody who knows us on Facebook in the Northolt group will understand that reference, and I'm sure there'll be a few chuckles.
Yeah.
So, Guy, could you just give us a brief history of Asteroid Day?
I could. Asteroid Day was founded to create an awareness of asteroids and possible implications that, say, maybe an asteroid strike would cause to humanity. So the more people who know about these things, I suppose the better.
Yep.
Yeah, I think it was the project of Gregory Richters, who who had this idea to make I think he's a filmmaker, and he made this film about an asteroid impact to raise awareness, not to sensationalize, because I mean there are movies already that do that, but to show that there's an actual scientific background. And then he worked to make this an international and yearly event. And so we have Asteroid Day now, which we celebrate every year on June 30th.
Yeah.
And then, of course, there was this impact in 2013 at Chelyabinsk, which
oh yes,
yeah, sure,
it's kind of a
it raised a few eyebrows, let's say.
I think it raised more than a few eyebrows, given the fact as one, I think, as one person put it, that will teach us to not to look everywhere else as well, because no one was actually looking in the direction that particular object came from. It was the last place anybody expected it to happen.
Well, I mean, it came from the direction of the sun, so there was little we could have done. But that's why we need to find these objects early, because if we find them years before their impact, we don't need to see the direction where they're coming from.
Now, also, as I remember, it was co-founded by Stephen Hawking, the astrophysicist, Rusty Swiggert, Brian May, of course, is there, and of course over 200 Apollo astronauts: Jim Lovell, Michael Collins, Chris Hatfield is involved, Brian Cox has signed up for this, Alexei Leonov, Kip Thorne, just to name.
Yeah, lots of great names.
Yeah.
Yeah, I mean it's been a great event last year, and of course we were all looking forward to it. I was looking forward to travel to London to meet Guy, to travel over from Germany. That's not it's not going to happen the usual way this year.
Nope, unfortunately.
Our plans have all changed quite a bit. We are looking forward to do the best we can to still celebrate it, but it's gonna be different. So
yeah, I think the thing is,
it's been
go on.
It's been interesting weeks. I mean, I'm glad that so many observatories are still running, but I'm also quite concerned about those that are not running. I mean, there's so many research facilities, and I don't want to turn this into a sad show, but I mean, there's so much going on at the moment, and there are a lot of researchers who suffer from this, and yeah. And
it's difficult to do everything online, isn't it? You can't all just keep doing things on Zoom. There are certain things that you have to be face to face for.
Yeah, there are facilities that just can't run under these conditions, and many asteroid observatories are still operating. So we haven't seen a huge drop in the number of observations and discoveries and so on. But
I guess people have more time at the moment than usual, so if anybody is kind of logging in remotely to kind of look for stuff like that, then there's more people doing that kind of thing. I noticed there was a lot of discoveries in this month's shipping forecast. I don't know if that's a reason for that. Maybe lots of people are at home.
Well, I mean, such things like the images you read in the discoveries, the real-time images and these archive images, that's all done remotely. That's stuff you can all do from home. It doesn't require you to operate a telescope.
No, that's good.
Yeah.
Well, one of the interesting things that I haven't noticed is that you can't buy a telescope at the moment. The telescope stores are open online, but apparently quite a few people have told me that even on eBay, trying to buy a scope is like impossible. They're gone. They're no longer there. They're getting snapped up like nobody's business. So perhaps,
Are they?
yeah. In fact, one of my friends was actually trying to buy a new mount, and basically it was like, yeah, right, nothing on eBay. eBay was cleared of telescopes.
Well, is there too much demand or too less supply?
Demand.
Demand, cool.
Demand,
well, I mean,
yeah.
that's good, isn't it?
Well,
Seen a massive influx of beginners into all the Facebook astronomy groups, which is a great thing for astronomy.
Yeah. I mean, the first moment I heard you say that you can't buy a telescope, I thought maybe they weren't shipping from. I mean, many are built in China, I guess. But yeah, if it's a demand thing, then I guess great.
I saw a Mac 127 Mac online. It was placed on Facebook, and it was gone within hours.
Blimey.
Yeah.
So obviously a lot of people. The same with cameras.
Yeah.
There are no second-hand DSLRs that to be had that are in decent condition. They've all been sold. Because I was looking for 60A.
Yeah, I mean, it's something you can do from your home, from your garden.
Yeah.
Yeah, so it's understandable.
And there will be people as well that are having to isolate, so they're not going to be listing things for sale that might have them at home because they don't want to go to the post office or interact with someone to collect it or hand it over. So I think possibly people are just keeping hold of stuff to sell for now as well. It might be a mixture of both.
Yeah. But
Well,
anyway,
interesting.
yeah, it's just something that I've been following for the last few days. So anyway, Asteroid Day takes place on June the 30th of every year, which is the anniversary of Tunguska, the Siberian Tunguska event, back in 1908. It's currently the most well-known smoking gun that we know of in human history that was recorded, and the UN proclaimed it to be globally observed on June the 30th of every year in its resolution. So the really nice thing is, of course, it actually raises serious and hopefully it gives the real facts behind asteroids and near-Earth objects, and really what we can do to protect the Earth.
I mean, we're fighting an uphill battle against some of the mainstream media. If you there was this asteroid a few days ago that made an approach, and some of the media was just going crazy. There was an article saying that NASA was following this asteroid, which was going to miss Earth by 3 million kilometers, but in case it would skip the Earth atmosphere, NASA was looking anyway to make sure it wouldn't enter the atmosphere, which is absolutely crazy.
It's just madness.
Yeah, and it's sad because I mean we are all following. I mean, Guy and I and lots of people are following these close approaches, and if the media is pushing these sensational articles about events that really pose no threat at all, then it's like the boy who cried wolf.
Yeah.
Yes.
If there's going to be an event one day that really needs our attention, then people will just ignore it, or will freak out like every week, which doesn't make a difference. It's so it's really difficult to tell people how to distinguish the real things from the sensationalism.
Because even some of the kind of space online magazines that are usually pretty good about that kind of thing have started to sensationalize things as well. I always ignore mainstream media when it comes to astronomy reporting, but there are certain other online sort of space and astronomy journals that are now doing the same thing, and it's very disappointing.
It is. It really is. And as I said, we're fighting an uphill battle, but we're fighting.
Yeah, I always get called a killjoy when I give people the actual facts of an event, and it frustrates me. It's a missed opportunity, isn't it?
Yes, if the big media are sensationalizing, then necessarily the real facts are more boring.
Yeah.
And that makes it really difficult to convince people that there actually is an objective threat behind this.
Well,
So,
the other famous media darling was Apophis.
Oh yes, I'm really looking forward to it. I really do.
Well, as I say, we're tracking Apophis. We're tracking it by radar. We know its orbit very, very well now. But yeah, it's every time it starts to fly by, the media goes into hysterics about Apophis is coming back. It's gonna hit the Earth. Yada yada yada. But there is only a infinitesimal chance of this, and I think it's so far out. I think it's 2265 or something. That it might be very, very close to the Earth that something could happen. 2265. That I'm not going to be about.
No.
Well, the thing about Apophis started shortly after it was discovered. And a week or two after it was discovered, it actually had a serious chance to hit the Earth in 2029. I think 4%. That was cause for concern, but it was ruled out shortly afterwards. And for some reason, either people don't believe that it's actually been ruled out, and someone is holding back the truth, or people don't understand that we have kicked this asteroid from the risk list, and that this risk is no longer one of actual concern. But I'm actually looking forward to this asteroid, because it's going to be an interesting event in 2029. Not because it's going to hit the Earth, it won't, but that Flyby will be so close by that we actually can see the asteroid with the naked eye as it passes by.
That'd be cool.
That would be interesting to see.
Yeah, should reach third magnitude. So.
Have you ever seen a naked eye asteroid?
There's never been a naked eye asteroid.
Okay, I wasn't sure if I just missed one.
There's not going to be another naked eye asteroid in the 21st century, and there's never been one in the 20th century. If you don't count Vesta, which sometimes reaches, I think, 5.5 or so. But
it's going to guarantee that it's cloudy when that happens. Then.
Well, it's Friday the 13th.
Oh gosh.
Well, there you go.
It's the day after my birthday. Yeah, it will be really nice. I mean, I know what I'm going to be doing. Mm-hmm. I think Guy knows what he's going to be doing, aren't you?
Tracking the asteroid.
Yeah, and I think we'll have to calm down a lot of people who are going to think it's another apocalypse. Which comet was it that caused the people to commit mass suicide? Was it Hale-Bopp?
It was Hale-Bopp,
Yes,
I think,
yes.
wasn't it?
Yeah. That's the kind of event we hopefully won't have. But yeah, and after this, I mean, that will significantly change its orbit, and it's always a bit tricky to predict what's going to happen after this. But you mentioned this chance in, I think, 2065. which is about 1 in 400,000, I think. And that's going to be ruled out probably shortly after the close flyby, because all that's holding us back from ruling that out at the moment is the uncertainty increasing after the flyby.
This Apophis actually features in a video game, I believe. Is it a game called Rage? The backstory involves the asteroid causing a kind of post-apocalyptic age, and the game is set around that. I'm not sure how many other asteroids feature in a video game with any factual backing up.
It's named after a character in a science fiction show.
Oh, is it?
Stargate.
Yeah, it's Stargate. The discoverers have been fans of that show, and they thought it's an appropriate name for the destroyer of the Earth, or what people thought might be the destroyer of the Earth. But, yeah, I think it's an appropriate name.
Well, to quote Jack O'Neill, "Stay calm, let Carter sort it out."
Well.
No, but again, going back to seriousness though. But I think the big problem is, even with all the work that Asteroid Day does do to actually make people or help people understand the realities, we've had Armageddon, we've had who was that actor that played McLean?
Deep Impact.
Deep Impact was the other one. Yeah.
Which is not a bad movie.
No, the entire budget went on the tsunami bit though, and the rest was kind of done on a low budget.
It's scientifically nonsense, but it's not a bad movie.
I thought Meteor though, with Sean Connery, was the better movie because
it's quite old, but it's nice. Yeah. Go on, Neil.
Sorry? Yeah.
Go on.
I was saying that to me it was the more scientifically accurate because it talked about how bodies interacted in the solar system, and that how a collision in the asteroid belt had pushed the shards of this particular asteroid into a collision with the Earth. Okay, so that's probably they're getting a bit more realistic scientifically. There's some good effects on it. The space mission being sent to investigate detoured to investigate it. Iron Man 2. Gee, did they foreshadow the Marvel movies? But again, they kept it they kept it reasonably sane when they were talking about using not an nuclear impact to shift it, but the detonation in space of missiles from 2 space platforms, ostensibly always pointing outward, of course, for such threats. But as I say, it's a bit one of those things. And of course, Grigori's film was 51 Degrees North, a fictional asteroid impact on London, and the human condition resulting from such an event, which had the music composed by Brian May. Now, there's a surprise for you.
Not really a surprise if you know the history of their friendship, but
true.
Yeah.
But most people, as I say, I've just pulled up an entry about Asteroid Day, so I've got some of the facts for us to chat with. So,
I think. You first.
I was going to say why don't you and Guy perhaps explain a bit more about what North Observatories do and how they take part in Asteroid Day, or how you guys take part in Asteroid Day.
You want to start, Guy?
Yeah, I can do. So at the observatory, our primary kind of goal is to help to confirm near-Earth asteroids that are posted to the NEO confirmation page on the Minor Planet Center's website. If there isn't anything suitable for us on there, i.e. too dim, etc., then we just follow up first apparition asteroids or asteroids that still have a little bit of uncertainty in their orbits, and we just submit the data, and that's the main things we do. But for Asteroid Day, we try and do a live broadcast of an asteroid moving across the field of view, as seen here from the North Branch Observatory.
What's your limiting magnitude there, Guy, for being so near London? I know I've asked you before, but I've forgotten.
If it's an important object, then we can spend a bit of time and get down to 20th magnitude, but normally we work down to about 19 and a half, depending on if there's any urgency in that asteroid.
Right.
Well, you mentioned it. We've got quite a bit of light pollution. Quite a bit is good. We probably have more light pollution than most other people who follow asteroids. But
the portal is about 8 or 9, isn't it, Daniel?
Yeah, it's. I think we sometimes have bottle 9 skies. So,
wow.
Yeah, I'm always surprised myself what you can do under city skies if you just spend a little bit more exposure time on the object. So I mean, people sometimes come to me and say, I'd love to do that, but I live in the city, and I can't even see the Milky Way from my garden. What can I do? Yeah, it's true.
The beauty of digital photography.
Yeah, if you wanted to do visual observations, you'd be stuck. But if you do photography, you can just crank up the exposure. I mean, you don't get the results you would get from a really dark site, but you do get results. So
yeah, and I guess the work that you're doing is not about producing pretty pictures; it's about doing the science, isn't it? So
yes. I wouldn't want to try to win an astrophotography contest from our side, simply because you don't get the you can't compete with someone at the dark side. But
well, having said that, Daniel, we were shortlisted in the Astrophotographer of the Year competition for one of the first asteroids that had ever been entered. So it is possible.
Yeah.
It is. It is, but I mean, we were concentrating on the data, not on the pretty pictures. Even though we've been posting quite a lot of pictures on our Facebook page.
Oh, it's good for public engagement to have that, isn't it? I know we do similar things with the UK Meteor Network. The videos that the cameras produce are not that nice to look at necessarily, but the science that you get from them is brilliant. And I think whenever I take a photograph, just even wide field, and I've got an asteroid in it, it's usually 1 pixel that's white, and knowing what it is that I've got a picture of makes me really chuffed with it. So I think it's cool.
It's authentic.
Yeah.
I mean, when we started our Facebook page or this observatory in general, I think there wasn't a Facebook page or any social media who were posting genuine images of asteroids in this way. At least none that I knew of. And so that was a gap we wanted to fill. And it's all black and white. It's just dots and lines, but it's the real stuff. It's what it looks like.
Yeah, and you think how far away those things are and how small they are. It's amazing.
Yes, and if you know that these images are not taken for the sake of the beauty of it, there's beauty in it, but the purpose of these images is to collect scientific data. So there was this that's a fun story from a few weeks ago, where we imaged the Bepi Columbus spacecraft, which was passing by.
Oh, I saw that picture.
Yeah, So the Baby Colombo spacecraft is an ESA mission on the way to Mercury, and it's been making an Earth flyby last month, so to bring it on its course to Mercury, and it's been coming close enough to be imaged from Earth with small cameras, and so we've been imaging this object, which is so small and so far away that it's basically looking like an asteroid. So we are basically doing the same thing as we would do if there was a close approach by an asteroid. So we've been imaging it. We've been taking this data like we would do for an asteroid, and we've sent it to the Minor Planet Center, saying here's some observations of the Bepi Colombo spacecraft. And the Minor Planet Center took it and said, "Oh, there's an asteroid. Let's have a look." And they actually announced it as an asteroid. So
gosh.
for a few hours, we had discovered 2020 GL2, which was exciting, but
We soon noticed that it wasn't an asteroid, and it was
it's-
retracted.
yeah.
Still good publicity for the Northrop Branch Observatory.
Well, it's been fun.
Yeah.
I've been talking to the people who work behind the scenes to try to prevent these things from happening. So there's usually a software running in the background that tries to identify man-made objects, because we've got so much man-made objects in space. The Minor Planet Center is getting data on these objects all the time, and usually they don't get announced as asteroids. But the problem is that their system can't handle objects that are not in an orbit around the Earth. So they can exclude man-made objects that are in low Earth orbit, the usual space junk, but they can't easily handle these objects that are flying by like an asteroid would. And that's a difficult problem to solve. But
Are the Starlink satellites causing you any problem, or are you kind of set up to avoid seeing things like that?
Guy, have you seen any?
None have interfered with our images yet, but generally we see plenty of satellites, and only very occasionally do they affect some of the measurements that we want to make.
That said, we did have satellites passing through, not Starlink, but the occasional satellite that did affect some of our data. That happens, and it's bound to get worse once Starlink has enough objects in space.
It's
basically
causing
a
us
matter of
problems. It's really causing us problems with our meteor detection stuff.
Yeah, I believe so. People have posted these images with lots of streaks. I think that's a case when it's shortly after launch.
Yes.
Yep.
And it's not nice, because even if it's just temporary, it does affect the data, and if it's crucial data that's only taken once, then that's really a shame. But these satellites are spreading out and getting a little bit fainter. But if you're spreading out, I mean, if they're building up their network and basically filling up the skies with these satellites, then it doesn't matter if they're spreading out. It's just this cloud.
Yes, I mean, and I know by the end of this year, I believe, is it 1,200 will be up. And accelerated the launch schedule, so he's putting 60 up every fortnight now in the coming weeks. And he's trying to get FDA approval for 42,000.
I really hope he doesn't.
I think they've rejected that initially,
Yeah.
thankfully,
The
but it's just crazy numbers.
Yes, it is.
what's happening is he's got FCC approval at the moment, as long as he doesn't interfere with American-based radio telescopes. So because some of his
Yeah.
downlink frequencies for GSM are perilously close to frequencies that are used by radio astronomers. Of course, the only ones that they're actually protecting are American radio telescopes based in the US. The rest of the world, unfortunately, has to make do and just deal with the interference.
I mean, it's
Because
it's American law. Yeah, it's American law. So
American law, sorry.
yeah,
Okay.
Well, theoretically,
Yeah, because if they go through our field of view of the radio kit, it's a mess. It's an absolute mess.
yeah.
theoretically,
I really hope it's gonna scale down really.
Fingers
I can't-
crossed.
I can't imagine what it's like to have 40,000 satellites up in the sky. I mean, I said we've had the occasional problem with satellites passing through our images. If that happens 10 or 20 or 100 times more often, then it's going to affect almost every image. And
Yes, I think somebody did run a simulation on this, and once everything is in its final orbit, just including the Starlink, not including the other companies that are planning to do the same, but
Yeah.
it figured out that every single professional telescope in an observatory in the world will have at least one satellite in every 2-minute exposure. So it's quite worrying.
And that's not only professional astronomers. That's the occasional hobby astrophotographer as well. So
They're always appearing in my photographs, but I'm not doing kind of hard science with my pictures, so it's an annoyance more than a danger to me, to my
Yes.
data. But yes, I
Yes,
don't like it.
But just what I wanted to say is this doesn't only affect professional astronomers. It affects everybody who's enjoying taking astrophotography. Of course, it really matters for those who do actual science with that.
Yes.
That's where we should try to really look at. But yeah, it's difficult. I mean, this goal to achieve worldwide internet for everybody is an honorable goal.
It is.
And it's but it's a question of what price we want to pay.
Yeah, I do have very big concerns. I know they're testing a sun shield on the latest launch, but that's not going to make any difference to telescopic views because you're going down to a much lower magnitude.
Yes, it really doesn't matter if the asteroid is if the satellite, if the satellite is just visible to the naked eye, or if it's magnitude 10, that's still too bright.
well, we had all this with the Iridium as well. People were looking for the flares, which was that's great fun. Everybody's looking up for the flares.
Yeah, and I did love Iridium flares because they were just not that frequent. They were a kind of special treat. There were only 66 active ones up there, and they were very pretty. They just flared for a few seconds and they were gone, and they were not moving around in swarms like the current ones are.
Yes, and they were avoidable because they were so rare and so predictable that you could, if you really needed to, you could schedule your observations to them, which I think was never necessary because they were just so rare. You'd have to be really lucky to ever see one in your photograph. But the difference is just the sheer number of objects and the likelihood that you're going to hit one.
Yeah, it's time will tell. Maybe in a couple of years they'll have a different solution. I don't know.
Yeah, but if they have a different solution in a couple of years, and by then they have 40,000 satellites in space, these satellites are not going anywhere. There's not really much option to bring them back and say, oh, we're going to bring them back and paint them black. I mean, they're painting them black now, but yeah, if they really find a solution after they have launched them, that's not going to help anybody.
No.
No, unfortunately, we don't have the shuttle anymore, so we can't collect them in groups and basically refurbish them or fix any particular issues.
Well, we couldn't anyway with 40,000 objects.
It would take years to do. I don't think there's the actual will to do it if we had a shuttle like.
No, the goal of these satellites is to be cheap and disposable.
Well, there's always the deep sea disposal area that they use for the old satellites, and they sent Mir and stuff into.
Sounds like a good place for them.
Yeah, that'd make a great diving site, wouldn't it?
Well, it's
in a
it's
bathysphere, yes.
It's an environmental issue. And I think people are aware now that it matters where you put your stuff if you're on the ground. But people aren't so aware that you can litter up near Earth orbit. And we've been speaking about this issue for science and for astrophotographers. But of course, if you have enough objects up there and they're colliding, then you're going to talk about the Kessler syndrome at some point. And then people, yeah, I mean, there have been movies like
Gravity.
what was it called?
Gravity, yeah.
Well,
but yeah, people aren't really aware of this problem, I think.
They also
Makes me sad though that people are getting really excited about going out and looking at these satellites, and there are so many astronomical objects that are exciting and beautiful, and people are going out and kind of getting really super excited about seeing the Starlink, and it's kind of such a shame.
Yeah. I mean, you mentioned iridium flares. I'm getting excited when I see an iridium flare because I rarely see one.
Well, they're all gone now, so
but
there are other satellites that flare quite brightly. But yeah, they are. It's a rarity, isn't it? It's something that's quite pretty and unusual. And
the Starlink launch is quite unusual still. I mean, we're going to get used to it, but it's new. It's exciting. It looks interesting. So, I mean, I understand that people get excited when they see it. People get excited when they see any rocket launch that they can follow. I understand it. It looks great.
So seeing a chain of 60 satellites is something quite mesmerising.
So, yeah.
It's a shame that that's what's made them go out and look, though.
Yes, of course. There's enough interesting stuff to look at.
Absolutely.
What observations do you and Guy have scheduled for the next couple of weeks and for Asteroid Day itself on the 30th?
Do we have a bright one yet, Guy? Do you remember?
Do I remember what observations we're doing, like, soon?
Yeah. I don't remember if there was a prediction for a bright asteroid this month.
For Asteroid Day, at the moment, there doesn't seem to be anything that we can broadcast live, but asteroids have been discovered all the time, so you never know, we might be lucky to find something.
Yeah, the problem with planning more than a few days ahead is that most of the objects we observe are discovered in the meantime. So we if there was a prediction for an asteroid passing by that's going to get bright, then that would be interesting for Asteroid Day. But I think we're just hoping for a bright one to be discovered in the next 2.5 weeks, and then we're going to check what's going to happen. But of course, there's always the chance of getting cloudy. Also, we could always do a comet. Yeah. There are quite a few interesting comets around. I think we've done a comet 2 years ago.
Yeah, we did.
For Asteroid Day. That was nice. I mean, people talk about the risk from asteroids, but comets are hitting just as well. Not as frequent because there are fewer comets, but it's called Asteroid Day, but it's not that there's a difference between asteroids and comets. It's just they're both flying through space. They're both occasionally hitting planets. So everything we are talking about on Asteroid Day is true for comets as well. So we could do, I think, C2017 T2. It's possible.
Yeah, we could do that.
Yeah, there's gonna be something.
Are you able to go into the observatory in person at the moment, Guy, or are you having to do things remotely?
No, I'm actually at the observatory now.
Oh, okay, cool.
But yeah, this year we've managed to do 100 days already, so we keep him busy.
Oh, good.
Yeah, we're lucky that that guy doesn't have to travel far to the observatory. There have been a few people who had to stop observations during the lockdown, and luckily we could continue.
Oh, that's good.
Yeah.
Yeah.
We haven't had a break really, so we've been quite lucky really.
Yeah, I think it's been keeping us sane over the last few weeks.
Yeah, definitely.
Just to keep a little bit normality.
It's a weird time for sure. It's like you say, it's good to have the normality. I was so pleased when I started getting talk bookings via Zoom, because I'm normally out doing talks all the time, and I was just stuck at home, and I did the first talk and I was like, oh my god, I've missed people so much. And
yes, I mean, even if it's just talking to a screen, it's talking to someone.
Yeah, it's really good. I'm really glad that we have the technology to do that kind of thing.
Yeah, and it's like recording shows like this. I mean, I can't visit Guy this year. I would visit him 2 weeks from now. I'd already planned it, but I mean, I can talk to you and other people. We are really lucky to have the technology to stay in contact.
Yeah, can you imagine being in this situation with a dial-up modem? It would have been hell, wouldn't it?
Or,
no Netflix.
Or with no technology at all.
Oh, yeah. You're doing a lot of reading.
If you're lucky, yeah. It's I can't imagine. It's we've been lucky on that regard.
Yep, a lot of. I know I've been doing a lot. I've actually picked up a physical book again. I've got my textbooks out. I've been using video links to talk to friends abroad. It means I can practice my language skills. they're better. Yeah. They're better written than they are spoken. But again, I've been talking to astronomers in Korea, to Japan, and to Thailand, and it's like, okay, what can I do today? I was on lockdown for 30 days, and I got to the point where I was just literally studying and going on to remote telescopes to image, really, and see what all my astronomer friends were doing around the world. It's certainly been interesting. I've never spent this much time on Facebook.
Really has been, yeah.
I've never spent this much time on Facebook as I have when I was on lockdown. But
Yeah.
oh boy, I was actually.
I've spent a lot of the time baking, like you, Nick. It just the constant. Oh, I'm hungry again. Oh, I'm going to have a snack. Oh, look, more snacks. It's been crazy.
Yeah.
Yeah. Some people are really catching up on things that have been lying around for years, and they didn't find the time to do them. But yeah, it's. I mean, I don't want to say that the pandemic has its good sides, because it doesn't.
No,
But,
there are some positive things that have come as a result.
Well, people have found ways to deal with it. I would
Yeah.
say that's the way I would say it, and yeah, that gives you some hope. It's difficult.
Yeah. But then again, it's also an opportunity to learn, really.
Yeah,
Pick up a book,
I mean,
go online.
yeah, I've been giving math lessons for I think it's A levels in the UK. It's Abitur in Germany, and I've been seeing all these school children or people who try to find a way to continue learning, or who are wondering how they should get their degrees, and yeah, we found ways. I mean, it's difficult. I think it shows a bit. I don't know how the situation is in England. Maybe you can tell me. But it's been really difficult here in Germany to switch to this digital teaching. That's been on the agenda for years, but people only really realize now how far behind we are.
I think most of the world is actually never really caught up on digital learning. The only people I think who really had a clue how to do it were the Australians, because they had the School of the Air, where you actually were on a radio, and you did your lessons by radio.
Is it because Australia is so remote that there are children who just can't travel to school anyway?
Literally, yeah.
Yeah.
Because, yeah. I suppose if we want some real excitement for Asteroid Day, we should ask Rich Kowalski to find us another possible visitor to near-Earth space.
Yeah, definitely.
I'm thinking of 2008 TC, which was 80 tons.
TC3, yeah.
Yeah, 4.1 meters, 80 tons, which entered the Earth's atmosphere on October the 7th, 2008. It exploded at about 37 kilometers above the Nubian desert. I think he's the only person I know, who's actually caught one of these things as it's about to happen and got it all logged up, and B, owns a piece of it, because I believe he actually has a piece of that in his collection.
Yeah. Richard has actually done it 3 times.
Yeah.
Yeah. 2008 TC3 was the first one, and then in 2014, I think it was the very first asteroid discovered in 2014. So 2014 AA that hit the Earth, and then I think 2018 there was
LA,
one.
Yeah.
Yeah, and we've had one, I think, discovered by Atlas last year. So they're getting more frequent, not because there are more objects, but because we are getting better at looking for them.
And I
So
think
that's really one of the things I'm really looking forward to actually see one of these objects with our telescope. So to have a predicted impactor, not one that's causing damage, but one of these small ones that we're basically going to follow to the ground.
That would be cool.
Yeah,
Yes,
that's maybe the observation I'm really looking forward to.
But to be actually able to own a piece of the asteroid you've discovered is just so special.
Yeah,
It's pretty.
yeah, it is.
I mean, I was pretty much squealing with delight when I got a piece of Vesta from a meteorite collector, and it's the first asteroid I ever got a photograph of, and I was like, I have a piece of it. It's so beautiful.
Yeah, I have a piece of 28 TC3, not quite small, but yeah, it's just amazing to think that that's the same thing that's been in this image.
Yes, it's incredible.
That's been in space. Yeah.
And since we're talking about Rich, his comet 384P Kowalski 2019 was recovered July last year at a whopping magnitude 20. Hidetaka Sato recovered it. So, and it's currently is actually showing currently on Yoshida's page. So the last update was the 25th of April, I think.
Okay. Yeah, that's it's always nice to have how should I say? I mean, there've been lots of comets Atlas, comets Catalina, comets Pan-STARRS, but I always like when it's a comet Kowalski or a comet Rankin, especially Rankin, because I know David. Congratulations from me too. I just second what Nick and Mary said in the beginning, but it's always nice to have the discoverer himself.
Yeah, for anybody out there who's
interested, it's more personal. Yeah,
absolutely. For anybody who's interested, the orbital period of 384P is 1,836 days. It was discovered on the 18th of October 2014.
Yeah, that's how many years? That's
1,836 days. Hang on a second.
That's about 6 years. 6 years. Yeah, quite short.
Hang on, I'm getting the calculator out. Where's my calculator? Oh, there it is. Okay. Divide it by 365. 5.03 years.
Yeah. Yeah, so we should really see it every 5 years, and basically the same position. Mm-hmm. Yeah, it's always nice to recover these objects. So,
it's like an old friend coming back to visit.
Yes, it's the same with the asteroids we've been seeing on a previous orbit. We're always getting excited to see old friends.
And of course, asteroids are also now deciding to get into the Cometary Act. They're growing tails as well. Now we're finding.
There seems to be a lot more of that lately, doesn't there?
Mm.
Well, it's always happened. There've been quite a few bright ones. I think was that 2013 US 10.
Mm-hmm.
That's been quite a bright comet. That's been classified an asteroid initially. It's always happened. There've been quite a few unusual ones in recent weeks. There's been this active Trojan, or I would say it's a pseudo Trojan. It's not really a Trojan asteroid or comet. Basically, it's an object in this with the same orbital period as Jupiter, but I think going the other way, and it's been found to be a comet just a few weeks ago.
I guess that there's a lot of different categories of asteroids and comet types, but there's always going to be stuff that overlaps between the two.
Yes, and there's just the occasional oddball that doesn't fit in any category.
And to be honest, it does kind of make life a little bit more fun, because you think, oh, I'm imaging an asteroid, and then 3 days down the line, suddenly it grows a tail, and
Yeah,
the MPC has to recategorize it. Oh, now it's a comet. And maybe you guys are sitting there thinking, oh, we actually imaged that around that time, and you can go back into your archives and probably have a pre-discovery picture before it
it's
was
possible,
actually reclassified as something completely different.
Yeah. And then there's the other way around. You've got I think it's A2019 something, quite a bright comet at the moment that's still classified as an asteroid, but it's obviously a comet. It's showing quite a bright coma and a tail, but it doesn't have a comet designation yet.
Oh, there's quite a few meteor showers are caused by asteroids, aren't there?
Yeah, which must have been active at some point. There's
2019
That's
LM4.
That's the Drogenak asteroid, isn't it?
Yeah,
Yeah.
it was reclassified around May the 14th. It was announced that it's been found to show cometary features.
Yeah. Of course, it's no longer classified as a Trojan. It's just an interloper, basically.
Then there was also 2019 K6 was redesignated as a comet.
Yeah.
2020 H9 on the 25th of last month. A/Pan stars. That was discovered fairly recently as well. So there's a lot out there, and of course, when we get lucky and we start seeing it doing atypical behaviour, then we have to completely revise the textbooks, really.
Yes, of course.
And
I mean, we've had Asteroid Gold a year ago, which suddenly showed a tail.
That was a very nice tail, wasn't it?
Yes, it was really nice. And we still aren't quite sure what caused it, but the dividing line between asteroids and comets, we've been saying this for years, that there's not really a dividing line between the categories. It's just maybe two extremes of the same thing, or it's just the human constructs that help us to classify things, but it's not really a physical difference.
I'm not that much of an expert on asteroids at all, but I was doing some research for something I was writing about Eros, and discovered that the reason it's covered in rubble, they said that it was due to seismic activity, and the seismic activity basically shook all the small craters into rubble. And I was really surprised because I wasn't aware that asteroids had seismic activity, but obviously they do. So that was something I wasn't aware of.
Well, the easiest way to get seismic activity on an asteroid is to hit it with something. So if there's an impact on the asteroid, then it's going to shake. But yeah, these objects are geologically active. There's stuff going on these seemingly dead pieces of rock, and we're just learning how dynamic these objects are. People have been really surprised when the OSIRIS-REx spacecraft arrived at Bennu and found that it's an active asteroid. It has occasional outbursts where it just throws small pieces of rubble into space. So that's another question. Is Bennu a comet? It's not. It's not really, but yeah, it's an active asteroid. There's a really fuzzy line between these things. And when we first started observing asteroids, or when people first started observing asteroids, we thought of them as just dead lumps of rock, like potatoes, and they're really not. They're really complicated objects.
Well, a lot of stuff seems to be bilobar as well, doesn't it, when we get to it?
Yes, these shapes are quite unusual. If you see these bilobate objects like Rosetta's comet,
Yeah.
Churyumov-Gerasimenko, and then you see objects like Bennu or Ryugu. These two look so similar to each other. You have to wonder if there's a common origin story to these shapes.
Or could they have been comets that have lost most of their volatiles, and when they actually start to they've been classified as asteroids because of that, and yet something may have happened, again a seismic event, that perhaps allows some volatiles that are trapped internally to finally escape again and cause a tail.
Well, if you hit an asteroid with if an asteroid is hit by another one, then obviously you uncover some subsurface material, and if there are volatiles still in the deeper layers of the asteroid, then you're going to get a temporary tail. We've actually seen that before in quite a few cases. So yeah, there's just a lot more diversity than meets the eye. It's not just dots. It's not just white dots on an image.
No.
That, and of course they're considered to be perhaps leftover material from the early days of the solar system, and they can teach us an awful lot about the early days.
Yes, and the fact that these objects are so diverse obviously tells us that these early days were quite diverse. Obviously, a lot has happened in 4.5 billion years, and we're not seeing these objects like they were 4.5 billion years ago. But there's still quite a lot we can uncover from these objects. That's why I'm excited about these sample return missions.
Yeah.
Yeah.
Now, a question for both of you guys. What would you like to see Asteroid Day taken into schools?
Yes.
I think that'd be a good idea.
Yes. Obviously, there's going to be. It's a question if there are schools this year. I mean, most schools have closed where I live, but in general, next year, if schools are open again, or this year where schools are open, of course, whenever it's possible. I think children are one of the target groups for every astronomy outreach. I think most of us got excited into astronomy as children.
True.
And yeah.
You never know who you're going to inspire when you do outreach.
Yes, and sometimes it just takes one event. I mean, I remember it was my uncle who had a telescope who showed me Saturn and Jupiter, and it was he brought his telescope and showed me that I could actually see these planets with my own eyes when I was 12, I think, and just that got me hooked. And I think it just some of the children may find it boring. I don't know. True. Some of them may find it inspirational, but it all depends on the presentation. And to answer your question, Neil, a definite yes.
I think the thing is that, but if we can get the children to understand the realities of well, if they can understand the threat and the actual science that goes into how we actually track these objects, how we work out the orbits, perhaps it's them that can debunk the bad journalism that the parents tend to lap up, for want of a better word. They're like cats with a bowl of cream. No matter how atrocious the science is in an article, if it sensationalizes something, and we've all seen the reactions across the media when there's a possible bright comet. We all remember how people got whipped up by Y4 Atlas, and then that went and shattered on us, and it was kind of not really a damp squib, because we did actually get quite nice for a short period.
Yeah, Guy and I really enjoyed this comet. We really enjoyed seeing it break up. I mean, I mean, we enjoyed we enjoyed following the event. It's something we don't
to keep observing.
Yeah, and of course, F8 Swan has now gone and decided that it's going to face its demise before it comes north properly. Oh well. We should be grateful for T2.
We're gonna get another great comet someday.
Someday.
I think the sad thing at the moment is, I think what's different compared to like 20 years ago is that most of these comets are discovered too early.
Yeah.
If you look back 20 or 30 years ago or longer, these great comets were found when they were much closer, and only the objects that were going to survive had the chance to be found at that time. So we're finding a lot more trash these days, and that increases the frustration. And it's sad because people get really excited about these objects, and then they get disappointed.
Yeah, I've noticed.
I think when you're teaching children... Oh, sorry, go on, Nick.
I was going to say, as an admin on a comet group, ever since Y4 was being prophesied to be a beautiful, brilliant, naked-eye comet, I've dealt with more people who just wanted to join the group, just because of that, but no real interest in comets or anything else. But
if it had turned out to be a really beautiful bright comet, then that may have been the thing that hooked them. But so they're just going to remember this comet as the thing that just didn't happen. Yeah.
Well, even when it was reported about how it was fragmented, it was really only in astronomy circles it was getting reported. It never made the news, really. That the comet had fragmented, and that there were still a couple of bright pieces, but it was just a case of, oh yeah, another disappointment, another event that we were told was going to be brilliant. Nah.
Yeah, and someday that's going to be a real brilliant event, and nobody's joining. White Wolf.
I think more of it is going to take everybody by shock, because actually a comet's lived up to its promise.
Well, a lot of time people that are expecting to see what an asteroid picture looks like, and they just don't look like that. And that's something I always try to make sure people have a realistic idea of what they're likely to see. Yeah.
It's the same when people join events at an observatory where they get that first chance to look at the planets for the first time, or to look at a galaxy, and they wonder why it doesn't look like the Hubble images.
Yeah.
Basically it's the same story. People have misconceptions about what these things actually look like.
I think the only thing you can guarantee that's going to put on a good display is going to be the moon. And of course, the Jovian Galilean systems, even in a modest telescope, do actually give you a very good image, and there is still a wow factor, I think, looking at the Galilean moons around Jupiter.
Yes. And in the past 2 weeks, of course, there was Venus and Mercury,
Yeah.
which which was nice. Got quite a few people looking at it that that I didn't know were, or that really haven't had any interest in astronomy before.
I also
So-
noticed that the UFO reports went up as well.
Of course, they do. Of course.
Venus in particular
I
is
mean,
good
they're
for
gonna
it.
wait. Yeah, they're gonna go down now. They're gonna go down now again because Venus is gone for the moment. But yeah, the planets are always nice. I don't know. Are there any good planets from the UK at the moment? I know Saturn and Jupiter are quite low.
Yeah, they're going to be low for a good couple of years yet, but they are doable. I'm seeing some nice pictures coming out from fellow astrophotographers in the UK of the planets. It's a planetary imaging, something I just haven't quite got to grips with yet, but we do have the kit to do it. I've just not really tried very hard, but other people are certainly getting good pictures. But you can get the atmospheric dispersion correctors that can help you if you've got the right setup to just kind of counteract some of the fog that you're looking through when the planets are very low. But one of the big problems is that they're above the houses then as well, and you quite often get heat escaping from houses and makes it look like a jelly. It's a bit wobbly.
Yeah, maybe I can do some advertising at this point. If people are looking into imaging planets and actually doing science with it instead of just taking beautiful pictures, I think the two things they can do is first join the project for Juno, which is always looking to get ground-based images of Jupiter. And secondly, I think there's a project since a few years ago that is looking for asteroid impacts on Jupiter and Saturn.
Yep.
So basically, you report how many hours you have imaged or filmed these planets, and if you've seen any flashes. And people have discovered asteroid impacts on Jupiter, quite a few.
Oh,
And
cool.
mostly amateurs.
Yeah.
Just because amateurs are the people who are most likely to look.
Well, my husband caught a flash on the moon years ago, and
Yeah, same
he
thing.
never did submit the results anywhere. He just didn't. I think he was questioning whether it was real, but there was clearly a white spot appeared in one image on an imaging run and was gone straight after. So it looked like a transient event of some sort.
I think.
I've always told him he should submit that, but he never did.
Yeah.
What I said about the planets is true about the moon, of course, too. There are projects who collect these observations for the moon just as well.
Sorry, Guy, was you about to say something there as well?
Well, it's always worth submitting if you've seen some kind of transient thing on the moon, because then other observers may be able to look through their data to see if they've also captured a similar event at the same time.
Yeah, it's good to get multiple versions, well, from different positions. It helps with data analysis, doesn't it?
Yeah, and to be sure if it's real, of course.
Well,
Yes, obviously, yeah.
there is still an ongoing project run by NASA to plot impacts on the moon. I think Brian Kludnik is running that. He also wrote a good book on how to detect and image such impacts. And of course, Anthony Weasley, of course, was the famous one that started all this off with the impacts on Jupiter. And then Chris Goh chimed in. He had one as well. And of course, brings it back to the perennial. Of course, there was Shoemaker Levy 9, which really woke
Yeah.
everybody up, and that was a cosmic 2x4 to
Yes.
what could happen
Yes.
to us. And of course, then they started to be able. Suddenly, there was this thing. Oh yeah, I remember seeing a chain of craters in a perfect line across one of
I think it's Ganymede, isn't it?
yeah, and they really suddenly realised that they'd also seen something very, very similar on the moon. So
Yeah.
obviously there has been a similar impactor that broke up, and in this case it created a chain of craters. So obviously the impacts that Shoemaker Levy 9 gave to us, which woke up the whole of not only just the astronomical community, but actually world governments to the fact that this could happen to us again. Chicxulub
Yes.
was the big smoking gun, the loss of the tertiary KT tertiary boundary impacts, and of course Barringer Crater. Now I've actually got some shrapnel from Diablo Canyon, which was part of that impact, I believe. So that's in my collection. I'm interested at the moment, and I'm probably going to go and speak to a certain person about getting a piece of the moon that's impacted on the Earth after another impact on itself. So that's where I'm headed.
Yeah, but Chicxulub and Barringer Crater, these are all ancient events, and with Shoemaker Levy 9, of course, we could see this is happening now, which really makes a difference. I think if people think something happened in the past, it happened to the dinosaurs, it's never going to happen to us. Yeah.
Have you seen a difference in people's opinions on this subject since Asteroid Day started? Is it kind of doing what you hoped it would?
I don't really have I don't really have much memory how it was before Asteroid Day, just because I didn't really do much before 2014, 2015 on asteroids.
Right.
But I can tell since we started in 2015, I think there's been a bit of change, but obviously the misconceptions in the media are still the same. We're getting more good questions, I think. Which is a good thing. There are more people who ask the right questions, who ask questions that are not concerned with whether somebody's hiding stuff from us or somebody is not telling me that I'm going to die next week because this work is going to hit my head.
Yeah, I find it extraordinary that somebody thinks that an entire globe can be duped into not knowing about something like that.
Yeah, but
it's tough, isn't it? Because on the one hand, you've got the press that are hyping things up and making people scared and talking complete rubbish, but at the same time, so we're kind of debunking that, but at the same time, we want people to take notice of this being a possibility. And
that's a difficult thing. It's a difficult thing about sensationalism. You have on the one hand you want to avoid making things more sensational than they are. On the other hand, you want to raise awareness and want to convince people that there's a threat. That's difficult to combine.
Whenever I do talks with the Cubs or in schools, invariably you get asked the question about when the sun will blow up and kill the Earth, and all that kind of thing. And the young lads absolutely love it, but then half the group look genuinely petrified. And I always find myself trying to say to people, yes, this will happen. Earth will get hit by something again, and yes, the sun will expand, but it's not going to happen anytime soon. So I'm kind of trying to make people not be scared, because I've had people in our village whose children have been in tears after these hyped up press stories, because they genuinely think that they're going to die soon. And it's a really difficult balance to get right, to get them to understand, yes, it will happen, yes, it could be dangerous, but don't go home and cry because you're frightened to go to sleep. And it's something I still struggle to find the right balance with.
Yes. So do I. It's a difficult problem. I think even JPL and some of the space agencies sometimes struggle with it in their press releases. It's difficult to find the balance. I think firstly it's important to try to get the numbers right, and if you report numbers, get them right. And the second thing is not to use these images of large pieces of rock burning up in our atmosphere that you often see on these news articles.
No.
I've seen some genuinely usually reliable people or agencies use them. And it just makes me sad because they're just trash.
It's clickbait, though, isn't it? Ultimately, clicks make them money, and they doesn't matter to them whether the picture isn't a true representation of the text.
Yes.
It's frustrating. And once one newspaper does it, within 3 hours, every single local newspaper has copied the article word for word, and suddenly the internet's flooded by the same story, and everyone thinks, oh, it must be true then.
Yeah, if everybody's reporting the same thing, obviously it must be true.
But it's literally word for word copied. It just like, oh my goodness.
Doesn't that make it even more true?
Yeah, exactly.
But the thing is, people forget that the atmosphere is being bombarded with all little bits of dust and rock on a almost minute by minute basis. So you report that, and then people get, oh my god, there's more stuff that we're being rained on daily. Well, yeah, but you've also got spanners, you've got nuts, bolts, the odd toilet floating up there somewhere, waiting to re-enter. What can you do?
Yeah, it's really I think even we struggle sometimes with trying. Well, you mentioned clickbait, Mary. I think if you report things too scientifically, then nobody's going to click on them.
No, I suppose it needs to be approachable, doesn't it?
Exactly. Maybe that's maybe I should say it differently. You can report things scientific, but you must remember that you're not writing a journal article. You're writing a news story, basically, and you have to change some. You have to change the style accordingly. Hopefully, without making it less accurate, which is the difficult part.
Yeah.
I think that's the real problem. If you make it, if you give everybody the facts, then it's dry. It's this is it. Don't panic. And then people just they get 3 sentences in, and then they're just switching off because they just don't have the attention span.
Yeah, if people are said, don't panic, nothing's going to happen, then nothing's going to happen.
This is the problem with writing articles about asteroids. If you say nothing's going to happen, then there's no article. But the numbers are normally correct in all these kind of media stories. Yeah,
that's the funny thing. If you actually read these sensational articles, there's actually the information in the article that the asteroid's going to miss by 10 million kilometers. It's somewhere 10 sentences in. But obviously the headline is asteroid skims Earth's atmosphere, or NASA is worried about asteroids hitting, or it's.
Well, they very often refer to the distance in terms of lunar distances, and the general public have no clue just how far away the moon actually is. They always think the moon is like literally on our doorstep, so if something's coming within 10 moon distances away, then they're like, oh my god, it's going to hit us. And like the moon's 300 and something thousand kilometers away. It's just crazy.
Can I have that in miles, please?
Miles. I can't remember the exact figure, but you can fit every planet of the solar system between the Earth and the Moon. The diameters add up to about the same. It's it doesn't matter even if it comes between us and the Moon. We're going to be fine.
Yeah, but then again, I think there are two misconceptions. First, obviously the scale. And secondly, the purpose of why scientists follow these newly discovered objects, because I've had the question: if you know that it's going to miss, why are you observing it? Which is a valid question. I mean, if you say we are observing these objects because of the threat from asteroids, then why are we observing objects that are not going to hit? And the answer is we are not only concerned about impacts now, but we are concerned about impacts within the next, for the future, for the next century, or for the next, even for the next 1,000 years if it's a really large object.
I guess you would also be checking if there's been any alterations to the predicted orbit, possibly?
Yeah, exactly.
Yeah.
You have, if you have an asteroid passing closer than the moon, then it's well within the gravitational well of the Earth. So its orbit is going to be changed quite a bit, and so it's going to be more difficult to predict where it is the next orbit around. So what we're doing when we observe these objects is not looking at them because they might change course and suddenly move towards us, but we're trying to help improve our knowledge about their position 100 years from now, which is a difficult concept to get across.
I think the thing is, it's just the time is, the whole time thing is difficult for us to visualize because we are so here and now.
Yes.
Thinking ahead, is this going to be a problem in 100, 200, 300 years? It's not really something we grasp. A lot of people grasp very well.
Yes, but if you there are two things. First, if you know that there's a large asteroid hitting in 100 years, would you want to prepare?
Exactly.
I think I would want to prepare. And the other thing is, there's no guarantee it's going to take 100 years. It may take 5 or 10 or 20. We are looking 100 years ahead, but that doesn't mean it's not going. That doesn't mean the event we're looking for doesn't happen sooner. If you look at objects like Apophis, when that was discovered in 2004. At that time it was discovered, the asteroid was, I think, 30 million kilometers from Earth, and we immediately knew it's not going to come any closer. But the initial orbit was calculated and was found to come dangerously close to Earth in 2029. That's the kind of stuff that we're looking for. That was 25 years difference at the time, which is a time scale I think most people should care about.
I think
and then of course we ruled out the impact in 2029 and all was well a few weeks later. But I think it's just important to realize that we are not concerned about where the asteroid is now and where it's hitting tomorrow. or what's going to happen at the closest approach. But we're interested in what's going to happen the next orbit around, or in the somewhat more distant future.
And I think the problem is, of course, people don't really appreciate what it takes to actually work out an orbit for one of these objects. They're so used to their planetarium software telling them, well, this is where Mars is going to be in 3 weeks' time. That's brilliant, but when you have a newly discovered object, it takes multiple observations, sometimes over a period of time, to actually work out that orbit, so you can start to predict with a reasonable accuracy where it's going to be in 10, 15, 20 or 30 years time. And I think that it's used to being able to plug stuff. Oh, I want to see where this is next week. They think, oh yeah, we can do that. Well, no, we can't, because when we discover something, a new object, particularly a near-Earth object, we know virtually nothing about it. We have no idea what the shape is yet. One of the good things about a flyby of the Earth, it allows us to either visually image it, and also to radar image it, and that allows that again that information about what the object looks like. That plays, to my mind, a very important part on how its orbit will be affected in the future. Is it tumbling? Is it or whatever? Until we know that information, we can't plug that into the equation, and therefore we can't say with any accuracy where it's going to be a week, month, year, a decade, or whatever further on.
Yeah, I mean, we talked about this movie Deep Impact. I think one of the biggest problems in that movie, and I know it's a decision to make it a good movie, but when this comet is discovered in the movie, I think what they do is they look where its position is, and then they plot an orbit from that, and they find, oh, that comet's going to hit the Earth a few months later. And that's really not what's happening. What's really happening is you see a new object, and you really have no idea about its orbit at that point. All you know is where it is now, and then you follow it. You image it a day later, then over a span of a week, and if there is an impact threat if there is any chance that it's going to hit the Earth, you're not knowing it immediately, just because there's not enough data. When I get asked, when I say, well, when there's actually an asteroid that's going to hit the Earth, when there's no chance to hide it, then what I mean is, by the time we know that there's actually any chance that the asteroid is going to hit us, that asteroid has been followed for weeks.
Yeah.
And by that time, not everybody, but every asteroid astronomer knows about it. And if you wanted to hide the knowledge about this object at that point, you'd have to convince every amateur astronomer in the world to keep shut. That's not going to happen.
I know.
NASA just has no way to know which objects they should hide from us.
Well, that's always been my thing. Everybody says, "Oh, well, NASA's hiding this, that, and the other." I says, "Yeah, hang on a minute. There's potentially 3 or 4 million telescopes out there in private hands. Do you really think NASA can shut those people up? They can't. We see something, we're going to talk about it. It's going to be on our social media. We're going to be contacting the big observatories, the Minor Planet Center, everybody, saying, hey, I've just noticed this. I saw this here. These are the images, and they're going to be working. They're going to be doing the number crunching. Somebody.
I can calculate an orbit on my desktop computer.
Yeah.
If NASA doesn't do it, I do it.
But that's just it. We are a bunch of people, us astronomers. We love to talk about what we've seen in the night sky, and we're going to be out there saying about it, and the news channels will get it so quick that you can't be hidden. There's no way you could actually gag an astronomer, because by the time the local news crew's turned up and he's done his piece, it's possibly gone out live. That's too late. The whole world knows about it. It can't happen. It just makes me laugh. Oh, you're being paid by NASA. I said, I wish I was. I wouldn't be doing the job I'm doing right now, mate.
Even if I was paid by NASA, I'm paid to find stuff that's gonna hit.
Absolutely.
Not to hide it. I mean, I'm not paid by NASA.
Yeah.
I wish I was. But
I think
the people that are paid by NASA are paid to find these things, not to hide it.
Yeah, they're paid to find them, to get other astronomers, particularly in the amateur community, out there tracking them, imaging them, so it can all be put into the orbital calculations, and that the more observations we get, the better, the more accurate the predictions are for where this object's going to be at any given time in the future. As I say, yes, we may be social distancing champions since the 16th century, but by gosh, we know how to use our mouths and tell people things.
Yeah. I think if there's one thing in the astronomy community that has worked really well over the past centuries, then it's communication.
Yeah.
There's always been a lot of communication between everybody.
And politics doesn't stop it.
No.
We're not afraid to talk to each other.
Even I mean, there might be people who give me a history lesson here, but I believe even in the time of the Cold War, there was communication between American and Russian asteroid observers.
Yeah.
They knew about each other's observations. They knew what the other one had discovered. It's just politics just doesn't matter for this kind of stuff.
It doesn't. We're not interested. We're here to observe, to image, and to learn from the universe. And we are going to speak out. We're going to say something. So trying to accuse us of being silent about the killer asteroid that's going to hit next week, sorry, that don't wash.
Well, I had a storm of, it wasn't with regards to an asteroid, but I finally got a photograph of some beautiful iridescence in an aircraft vapor trail. And oh my goodness, the pictures went crazy online, but I was just swamped by chemtrails people, mostly speaking in another language. So I was having to Google Translate and then having to try and reverse Google Translate, saying it is just water, and try and stop people from being numpties. It was painful.
Yeah. It's difficult to deal with conspiracy theorists.
It's kind of almost pointless trying, because I'd rather spend my time talking to somebody that wants to learn something from me, because I can talk for 20 hours solidly to these guys. They've already made their minds up and I'm not going to change it. So I tend to just walk away, to be honest. I can't. Yeah. But with this one, I really just, everybody that mentioned chemtrails, I just felt obliged to just remind them it was nothing but water they were looking at.
I mean, I said before, I'm under the impression that I'm getting more good questions and less of these conspiracy theory questions.
Good.
I mean, I don't know why. Maybe the people who talk about conspiracy theories are too busy right now talking about others.
I think that people are actually beginning to take the effort to learn something. instead of listening to the local idiot who thinks he knows everything, including where the origin of the Big Bang was situated in the universe.
That's a valid question. It needs some thinking to realize that there's no point in the universe where it originated. But if people ask genuine questions that sound stupid to an expert, it's still a genuine question.
I still get asked about what's the meaning of the life of the universe and everything, and I automatically
42,
say,
of course.
yeah, and then why? I said, because that's the length of time a mini black hole can survive, as it's unable to feed because its small child radius is too small for it to eat, and that's why the LHC will never create mini black holes which are going to eat their way through the Earth. It's perfect because you still get the people who say, "Oh, it's going to destroy us. It's going to create a black hole." It can't, even if it can make a mini black hole, it can't feed. It's going to last for 42 minutes and go poof in Hawking radiation. Goodbye problem. You're not going to know about it. Thank you, Douglas
I never
Adams.
realised the Douglas Adams number actually had an origin.
It doesn't.
Oh, okay.
It doesn't. He was asked about it once, and he said he's really annoyed about all the people asking. He's so annoyed. He's been so annoyed that he thought about publishing a book where he said he's been miscalculating. It's actually 36. So there's absolutely no meaning behind this book.
It's nice that you can turn it and give a scientific explanation.
It's a small number. Every small number has lots of appearances in lots of calculations. There's a joke theorem in mathematics, the strong laws of small numbers, and it says that small numbers can't meet all the demands that are made of them. There are just not a lot of small numbers.
So, okay, here's a hypothetical question for you guys. You are the Minister for Education in your respective country. How would you bring Asteroid Day into the schools?
Contact local government, I suppose.
Sorry, what was that, Guy?
I said contact local government would be some sort of place to start if you were going to get Asteroid Day observed in schools.
I would start thinking about how to teach the teachers. I think it's most teachers have no idea about astronomy. It's not part of their education. Even if you study physics for teachers, there's not a lot of astronomy. So I would start to talk to the teachers, and then people are gonna ask about how to pay for it, because everybody is concerned about money, and people try to bring their children into a working job as soon as possible. I think I would start with the teachers, and then try to convince people that there's a financial benefit from inspiring people in science, and
aerospace.
I think it's not. Yeah, I think it's not so much about asteroids. I think that's too specific. I think it's important to bring astronomy into schools. There's too little astronomy in schools in general.
And it's one of those subjects as well that can cross the curriculum so easily because you can do drawing with it, you can do model making, you can do
And
maths, you can do
yeah,
art.
and there's
It's amazing.
and there are so few topics in science that have the potential to really fascinate children. It baffles me why it's not part of the curriculum more than it is. And once you have introduced astronomy into the curriculum more than it is right now, I think it comes naturally that you can ask about including Asteroid Day.
It's certainly stuff to think about. Maybe we should all start a petition. Let's have more astronomy in schools.
Yeah.
Well, the teachers are kind of sometimes quite scared to try and teach it because they don't feel confident enough, and I've certainly helped with that.
That's what I meant with talking to the teachers first.
Yeah, teach the teachers because even just giving them a few pointers, because they're obviously intelligent people to be doing the job they're doing. They just need a little bit of hand-holding sometimes.
Of course they do. They're not experts they're not astronomers.
No.
Most of them. So. Yeah.
And of course, there's always the local astronomy clubs, but they would be a great resource for the schools to use.
Yes, there are observatories. There are lots of local clubs that would just be glad to reach out to children. I would be. We've been recording for Astro Radio last week. And Pete Williamson asked us if we what we think about doing outreach in schools, and I'd love to. I've never been asked.
Really?
I've never been asked if there's a school who wants to do it. I'd be glad.
I love it. I really do. It's just so rewarding.
Yeah. Not just for, I'm sure it's got to be, it's rewarding for you, but it's also rewarding for the children.
Our children always love having guest visitors coming to do stuff with them, regardless of the subject that's being taught. But the feedback I always get when I've done something in a school or with the cubs or beavers or whatever, the children are just buzzing and talking about it for days and days afterwards. And it's not me personally, it's just the fact that they are so enthused about the subject, and it was exciting to have a different person there and bringing exciting posters in and new materials, and it just really kind of motivates them to want to learn more about it. And it doesn't take that much prep to go and do a lesson to a junior school class.
No,
it really doesn't.
It doesn't. And it's, as I said, it baffles me why people don't realize the potential to bring people into STEM subjects. There's so much potential.
Yeah, there is.
What would you do? What would you do if you were your minister, Nick? You asked the question. What's
to be
your
honest,
answer?
I personally would like to see. Well, you can do astronomy at GCSE, which is the old O levels in the UK. So the subject is there, and there is a set curriculum, and there is a series of exams across the various exam boards in place. It's perhaps getting that back into the schools, because it was in the schools for a while, and I think a lot of it was just a case of there were so many subjects that were being put in at GCSEs that the schools were cherry picking really. Stuff that they thought was going to boost their table, their position in the educational tables, either nationally or locally. So I think it's really a case of finding really another Patrick Moore. Because he was one of those...
All the schools that I know that have done astronomy GCSE, it's been an additional subject that kids do after school or during lunchtime. It's never taught as part of the school day.
But yeah, it could be part of the physics class because of the relationship
It
between
should
physics.
be.
Yeah, it, it seems
But
to be
right now,
exactly
I
place.
don't know. I don't know how the situation is in the UK, but um, teachers have so much trouble getting all their schedule for the school year because their schedule of what they have to teach the children is so dense, and they have so little time to divert from it in a way they are interested in. So I don't know how it's in the UK, but it's really turned worse in the last 5 or 10 years here in Germany.
I think in a lot
I
of
do know
cases.
that there is one school that does a lot of astronomy, but that's the Harrow School,
Right.
and they do have quite a nice telescope up there, and they have a department that specialises in astronomy and physics, and they have about 20 pupils who are currently studying astronomy, and I visited them, and I was trying to get them interested in asteroids.
Oh, brilliant. And I did a lunar sketching workshop with a group of GCSE astronomy pupils at a local private school, and they were really enthusiastic about it, and the teachers were really into it. It needs the teachers to be into it. I think you're absolutely right that you need to talk to the teachers first, because once you've got them on board, the kids will just follow their enthusiasm.
Yeah, I think you need an example to lead. Yeah.
Well, Bedford.
You can always tell when a teacher doesn't enjoy the subject they're teaching, can't you? And it's
Yes.
And the children are going to notice, and they're going to exploit it. Of course they are.
I was going to say, Guy said about Harrow School, Bedford School, near me, they have their own observatory. The Piazzi Smythe Observatory, I believe it's called. Bedford Amateur Astronomical Society actually meet there, and they have access to the telescope as well. So there are some of the schools have found a way to either get it in as a voluntary subject or have the subject there because it's always been part of the school, because if there's an observatory attached. So I think it's a case really of building bridges, so that the schools that don't have it can get the access.
Yeah, and I think there's one more thing. Of course, you say the school has its own observatory. Most schools don't, and most schools don't have the money to build one. But I think you don't need one to teach astronomy effectively.
Not really,
well, you can use the Liverpool telescope. There's the National Schools Observatory will freely let people use the 2-meter Liverpool telescope. The stuff that Pete Williamson does with Vaux, he does loads of workshops in schools teaching kids and teachers how they can capture data live, and you can do it live in the classroom because it's dark on the other side of the world where the remote observatories are. So you can, and as a kid, if I'd have been involved with catching galaxy pictures taken with the 2-meter telescope, I just can't imagine how much my mind would have been blown. Because I've wanted to go to space since I was 4 years old, and if I'd seen a picture like that, that would have been me
doing astronomy for a career, like properly. So
Yeah,
the facilities are there.
it's so easy to get people into it. I just remembered meeting a teacher last year who is actually teaching astronomy here in Germany, and who's doing a workshop. Who had been doing a workshop with his students, who got the opportunity to actually take pictures with an observatory and to look for asteroids. So they actually did an asteroid project on that.
Fantastic!
And they found this main belt object which they followed, and later got a designation for it. And I think that one is that won some prize for the student. So it is done. There are projects like that in schools.
A lot of schools just aren't aware of it.
No,
They
they
don't
aren't
know
aware.
that it's available, so
They have too many other things in mind. Maybe they're too coupled up in day-to-day business.
I wouldn't. I mean, being a teacher full time is not a job I would ever want to do. So
No.
I do feel for them.
Yeah, the teacher I mentioned is an amateur astronomer, so it's really his project that's a case where it's really about the teacher. If it wasn't for him, that project wouldn't exist.
No,
So
just needs one though, doesn't it? And then
it
gets
just
the
needs
ball
one.
rolling.
Yeah. And I think there were other schools that thought, oh, that's an idea. Why haven't we done that? Yeah, it's winning them prizes. Why don't we win those prizes? Yeah, it goes a long way just to have a few people who are excited about something.
Well, we've actually been going for 2 hours 10 minutes.
Crikey!
Good.
Yeah. 2 hours 10 minutes and 38
Time
seconds.
flies.
Time flies. Yeah.
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 So, I think
I guess it's bedtime for us.
it's gone midnight already.
I know. It means it's actually dark. You got to wait till nearly midnight for
It's
darkness.
1 o'clock. 1
Oh
o'clock
gosh,
here,
it's
yeah.
one for you.
But it's been a nice evening.
Yep, it has. It's been good fun. So, okay, so let's.
Yeah.
I probably we really should, I suppose, really wind this up at this point. So, what would you like? How would you like to spend Asteroid Day 2020 this year? How would you prefer to spend it?
Guy?
Personally, I would spend it at the observatory observing the close approach of a near-Earth asteroid, and then broadcasting that live.
That would be good. I'd like to do something similar to last year, where we had this question and answers. Last year we had it from the observatory in London. I think that's something I'd like to do this year again. So maybe we should
Try and do
ask.
that by video link this year.
Yeah, maybe we should ask on our Facebook page for some questions for a Q&A session.
Yeah.
That would be
That
fun.
would be fun, I think.
That
Yeah.
would be fun.
Yeah. And of course, I would love to go to London. It's not possible, but I would really like to see the event going forward anyway. Because
You'll have to video call with each other,
yeah,
and you can
we have
pretend
to
you're there.
we have to video call. We have to improvise. But yeah, I really hope people. For the past 2 or 3 years, people really got excited about it, and I'd really like to see that again, despite the situation.
I think it will be back, and of course there'll be all the online events around the world.
Yeah.
I think we'll still have a good Asteroid Day, June 30th. Everybody, log on, Google Asteroid Day events, and you'll be able to see exactly what's going on around the world.
Asteroidday.org on the website.
Yep, that's the place.
And if you want to see us on Facebook, it's just search for Northolt Branch Observatories. Or on Twitter as well. It's
Yep,
on Twitter too.
Yes, you're on Twitter too. I follow you both in both places, so I shall be following what you got. Hopefully, I'll have the day off. And if I do, I know what I'll be doing.
Good.
Excellent.
Absolutely.
Thank you all.
Enjoy the rest of your weekend, everybody.
Yeah, have a good Sunday, everybody, and
Stay healthy.
stay healthy, stay happy, and look up, as Maggie says.
Keep looking up.
Yeah. Good night, everybody. Thank you guys
Bye,
for coming on the
everyone.
show, and we'll have to have you back again soon.
Good night.
Yeah, thanks, guys. Bye.
Good night, everyone.